Alright guys, this is a video on how to do graphical vector addition on my crappy setup here, just trying to figure out how to do this on paper. So I've got two vectors here, 120 newtons at 30 degrees and 72 newtons at 125. So we're just going to show you how to add these vectors. First thing you need to do is decide a scale. Now the best way to do this is trial and error. You know that a general paper has something like between 20 and 25 centimeters in width, and probably somewhere between 30 and 35 centimeters kind of up and down. Let's see, this one is, I say that, actually this one's 28 in height and about 21 and a half side to side. So it gives you an idea like what you need to aim for. I'm going to choose a scale, and you need to write this down. I'm going to choose a scale of 12 newtons equals 1 centimeter. Okay. First thing I do is I show the work on one of these. So I'm going to come here. I'm going to go 120 newtons and 12 newtons is 1 centimeter. So this is 10 centimeters. Okay, so I've divided by 12 to get my 10 centimeters. And then what I'm going to do is I'll just do the work for this guy right over here. So this should be 6 centimeters. So just 72 divided by 12. So show the work once, but if you have 2, 3, 4 vectors, you can just do this kind of in your calculator or whatever. Okay, so now we know that this thing should be 10 centimeters at 30 degrees, and this one should be 6 centimeters at 125. So these lines here just help me see where I've got to put the camera. First thing you're going to do is you're going to set an XY axis. Doesn't need to be terribly large. One advantage you might have, I suppose I could have chosen to have here as well, is lined paper, so you can kind of make sure these are appropriately up and down. Then, let's go ahead, and the first thing that you do with any vector is set your protractor. So I've got my 0 here, I've got it lined up on the 0, lined up on the 0. I'm going to make a little mark here at 30 degrees, okay, to indicate that anything between here and there is a 30-degree angle. Now, since my first vector is at 30 degrees, 10 centimeters, I'm going to draw a line along here that is 10 centimeters long. So apologies, I'm kind of doing this a little bit off camera. Trying to do this on the spot. There we go. Okay, so here we go. This vector here represents, we'll call this vector A. You put a little symbol like that just to indicate that it's a vector and not just a standard variable. But this here is vector A. That's 30 degrees, and this 10 centimeters represents 120 newtons. Okay, now from the very end of the previous vector, again, this is where your lined paper is going to help you a lot more. I'm going to reset my XY axis here for my second vector. So I need to go 125 degrees, and that's 125 degrees from the 0. This math doesn't know what order I'm going to do these vectors in. So once again, I'm at a new vector. So when I get my protractor out, I reset, I'm at 125. Oh, I'm going a little bit off my page. I was planning on not moving this. This is not going to happen. Okay, and I'm going to go 6 centimeters. Okay, there we are. Yeah, right at the end there. Alright, these represent my two vectors. If I had more vectors, I would just keep going from the end. Same thing, set the angle, draw the line, and now this, we'll call this vector B. Now, you don't have to label them the same way that I am here. It's just nice to kind of help yourself as well as anybody looking at it right now. Okay, once you've added all the vectors, once you've put all the vectors together, we're going to get our resultant by going in a vector from the origin all the way out to where we ended. So right here. To get a final answer, the first thing I'm going to do is I'm going to put my protractor down. Oop, I didn't quite get that exactly right. We'll check this in just a moment. But it should be from here, so my angle might be a little bit off. So I check my angle on this. Remember that, okay, I've got some larger numbers out here. I got to be smarter than my protractor here. I'm in the first quadrant, so I should be 0 to 90. So I have 62 degrees. 62 degrees is my final angle. Okay? Then, to figure out what the magnitude is of that final vector, I will actually measure the length of the vector. And I have 11 centimeters exactly, because tenths very much matter here. So I'm going to come down here. Lost my camera there for a second. I'm going to write down 11 centimeters. And I'm going to do the opposite of the scaling that I did at the very beginning, where I went, of course, from newtons to centimeters. I'm going to go from centimeters back to newtons by just going 1 centimeter is 12 newtons. So what should that be? That should be 132. And there you go. So once again, running through that really fast, you have scale, so that you're down an appropriate size to your page. Make sure you show me that scale. Okay, convert once and then do the rest. Then for this, we set the angle, we draw the line, we set the angle, we draw the line, and if we had more, we would keep doing that. The final thing is we draw the resultant vector, measuring its angle, the protractor, from the origin like we just did. Again, just setting that down like you would at the very origin, just like I got my 30 degrees right here. This gives me my 62 right here. And then we measure the length of this line with a ruler. And the final thing is we scale back that to the original. So now we have our final answer, which is 132 newtons at 62 degrees. That's how you doing.